So I want to run through the proposal process. This project, we already have received a contract. That's why I'm doing a proposal. But when we receive a contract or when we initially create the proposal, the process is the same. In this case, I'm starting out looking at the project. I want to go to the documents. I've already been through, made the shop drawings, but I'm looking for the plan information. And here I find links to the project files. So I'm going to go ahead and click on that. I'm looking for all of the project documents that you would need to create a proposal in the first case. So I have the job file, go into the plan folder, and I see all of the information here. I'm going to go ahead and download that to my computer. Now I have the plan set up, and I prepared a little takeoff schedule just to help walk through the set of information that we need to get to create a proposal for the glazing. What I'm looking for is, to determine what kind of window system do they need, and if it's impact resistant, then the ultimate wind speed's over 140. I want to understand the thermal performance required because the glazing system could be insulated, maybe it needs to be thermally broken, etc. And then the structural design pressures are going to help me qualify a system that is adequate to resist the loads required. Now I'm going to find this information throughout the project and keep track of it in this document. Right off the bat on the cover sheet, I can see that it was dated 5/12/23. Here we have a revision issued. That's 10/18/23. And this is the sheet where I find the drawing index, 10/18/23. So I'm going to put in here 10/18/23. I don't need to keep track of the dates for all of the different pages, but I do want to include that information in the submission drawing so that I have an anchor point relative to the plan version. So just by using the drawing index, I've been able to fill out the information in this table. The code compliance summary, I'm taking that to be the project data. And then, the names of the criteria and the way that they name it in their drawing index, it could be a little bit off. I put some ranges in here because I'm not sure the information that I'm looking for. I think it should fall somewhere in here in one of these pages. For example, if you look at the A4 section, frame opening schedule, that may be the window schedule. I don't know. Door and storefront elevations, that could be it. Door details, storefront details. So I have A4.3. I'm pretty sure that's going to show me the window cross sections, but you get the idea. It gives me a kind of a structured starting point where I don't have to go back and forth. So here we are on A0.1. This tells me the ultimate wind speed is 148 miles an hour. They also included some Florida product approval data in reference to a storefront system. The product approval is 142182-R13. So by looking up that product approval number, which they had wrong, I just added the decimal before the 2. But I can see what kind of storefront system it is, and I could open up the instructions and look at it, but I know it's an aluminum, non-thermally broken, impact-resistant storefront, a typical center glazed storefront system. Next, I want to check on the specifications and see what information is provided for the doors and windows. I jumped around a little bit, found some of the other pages when I was looking for the specifications. Now that I noted the page numbers down, now that I found the specifications, I want to look at the aluminum storefront. That's going to be the CSI number 084111. If you are looking at specifications that are organized in the CSI format, you'll want to find that number. But as I look through here, 2.1a, it identifies YHS 50. That's the product approval that I just found. And then after H, looks like point 1, it says color, see drawings. So I'm expecting to find the finished specifications on the drawings. I don't see any information about a warranty period on the storefront frame finish. On the same page, I find the glazing specifications. That's 08800. And here they're providing, let's see, basis of design glass product, Viricon VE-2M. They go on to say visible light transmittance 68%, winter U value 0.29, summer U value 0.26, solar heat gain coefficient 0.37. Okay, that's important. U factor, solar heat gain, those are code regulated values, but for the whole product with the frame and the glass, these specifications are only for the glass. So they're telling us a very specific type of glass, but they're not relating it in the way that the code regulates this to the whole system performance. So let's just keep it in mind. What the plans reflect is an aluminum storefront system with glass having a 0.26 to 0.29 U factor with a solar heat gain coefficient of 0.37. So we'll see what other requirements we find. So in the course of looking for the window schedule, I managed to find the elevations and I jotted down that page number. Now here we are on A 4.0. So I have some type of an opening schedule, a hardware schedule, and general storefront notes. Storefronts based on YKK, clear anodized, glazing is insulated unless otherwise submitted, UNO unless otherwise noted, submit manufacturer product approval data for approval by the architect. The contractor shall submit details for anchorage of all storefront to the building department. Right. Finish requirements. Refer to exterior finish schedule on sheet A 3.0 for door and frame finishes. Refer to finish schedule on A 2.1 for paint finishes at interior doors. So we're going to look at A 3.0. I'm going to make a note of this. Let's see. Specified frame finish. A 4.0 to A 3.0. Okay. While we're here, we want to take a look at the frame opening schedule. It looks like this is really a door schedule. The material that the door is made from, aluminum and glass, the lock function auto slide. So 1.01, it appears to be an entry door, type B. I don't see other aluminum and glass in here. Storage unit doors, aluminum frames, okay, A, B, C, D, okay, and let's see, door type, okay, so we want to see door type B. Let's take a look while we're here. Threshold T2, finish, remarks 5 and 15. Lock function, entry. Hardware 09. So let's see, remarks 5, aluminum storefront components, clear anodized. 15, minimum 10-inch bottom rail. Okay, and hardware set number 9. Hinge, passage set, no, that's number 8. Number 9, continuous hinge, deadbolt, mortar cylinder, indicator, thumb turn, push pull bar, surface closer. Okay, so a basic door with a 3-point style lock. door keying, 4 different door keys for the facility. Doors are to be keyed per the following. Front door key, okay, so it looks like the key for the front door is totally independent of everything else. And I'm only looking for one aluminum and glass door, 1.01, the entry door. I'm going to go to the next page. Okay, this is more properly what I think of as a window schedule. So window schedule, I'm going to update that to 36 in my drawing, and I see here I have a type A, a type B, a type C, a type D. Okay, and then the door schedule was referencing door types. So that's type A, that's type B, type C. If I go back to the door schedule just to show you, type B, C, A, C, C, that's what this is referencing, is these different, door type drawings. So what I'm looking for is a type A, a type B, type C, type D. And it's really nice, they have included some cross-sectional details for the frames on sheet 4.3. 4.3, 4.3. So I'm going to make a note, cross-sections A4.3. Okay, good, I already have it. And I just happen to be on 4.1, so I'm going to say 4.3 is going to be on page 38. Now, I already found the floor plan. It's on page 12, so I'm just going to type that in here, 12. And let me see. It kind of looks like a window, kind of, sort of, but not quite. Okay, that for sure is what I expect to see as a window, and it says type B. That says type A. So I'm going to just get over here to type, the label type is A, B, we had a C and a D, and then the door labels 1.01, let's see, 3-point lock plus a continuous hinge. We could go back to the door schedule. I better just put number 9, so that way I'll go back and reference that later. So I have 1A and 1B so far. Just going around the perimeter of this building. Okay, this appears to be 8.15. I'll have a look at that. Within this office, I don't see any kind of interior glazing windows or doors. There weren't additional doors on the door schedule called out as being aluminum doors, so I don't think that we have interior doors in here. And we want to find our node 815. Let's see, 815, automatic sliding entrance door. Okay, so that's an automatic door. In this proposal, we're going to just skip the automatic door. Let's see what's on our next page. A 1.01, first floor dimension plan. Okay, I'm expecting to get the dimensions from our window schedule, the glazing elevations. Second floor plan, building A. Now, we'll just start in the bottom left. Got CDC, so I have 2 C's, and I have 1 D. Okay, top left. I got nothing on that west side. I got nothing across the south until I get over here, and I have 4 C's. So that's going to give me, I'm going to put equals 2 plus 2 plus 2. And this was 1 plus 1 plus 1. Okay. I don't see other, okay. I'm going to go to the next page. What do we have here? Roof plan. I must have skipped something. Third floor plan. Okay, third floor. CDC. 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 We probably don't have anything else around the rest of the building's perimeter. I don't see anything. Okay, so what we have is 3 CDCs. So for C, I'm going to put 2 times 3. And for D, I'm going to put 1 times 3. Okay. That gets us onto the roof plan for building A. Oh, I don't know what buildings B, C, D, and E are, but looking at the floor plan for building D, it looks like it's just a small kind of detached storage building. It looks like building C is kind of the same thing. So I don't expect there aren't any window tags around the building B or C. No window tags. Yeah, so I think we're gonna rule out any expectation for finding windows on B, C, D, or E. I'm going to go back to page 29, which is where I previously noted the building elevations are. So the south elevation of building A, I'm just going to bring this up to full size. Okay, so they have these notes here, 941 and 944. I think they're trying to simulate a window with stucco. 941 acrylic ephes. Okay, so that's stucco. Control joint. Okay, so that's what they're doing. They're going to simulate a window using stucco. Okay, cool. But we have CDC, CDC, CDC. Okay, so basically 1, 2, 3, 4 of the same basic window arrangement. That's 4, 5, 6. I have a type B and a type A. And then this 7, 4, 1, 7. It's not, let's see what 7, 4, 1 says. That's right, we just looked at it. It's acrylic ephes. Okay, so that's ephes. There's our elevation A. Okay, so between the south and the east, we have 1, 2, 3, 4, 5, 6, and then A and B. So if I have 6, so I'm going to have 6 Ds, I'm going to have 12 Cs, 1A, 1B. Okay, and then that's what it looks like. Let's see, we have this note from before about see A3.0. So let's go back to A3.0 and see what kind of finish. Exterior finish notes. Okay, I don't see anything pertaining to the glazing system finish here. Okay, here it says aluminum storefront entrance system, refer to frame opening schedule and exterior finish schedule. So the frame opening schedule is what they called page 35. Yeah, and here it is, clear anodized. Okay, so we have specified frame finish, A 4.0, general storefront notes. Got it. Next, we can take a look at the cross-sectional drawings of the walls at the storefronts. Just good to know. We're looking for kind of break metal trim or what is required. So they show a sealant joint inside and outside. We're not normally including extra sealant because it's an extra cost. And the way that, of course, the way that this is drawn up, the brake metal design is suboptimal. Sealing the frame to the brake metal cover, and you have all this extra sealant that is definitely not ideal. So we could probably build this in a much better way. Okay, so they have some storefront sill details. So S2, that's probably on the upper second, third floor. S1, that looks like it's the ground floor kind of thing. 8.02, okay, I think 8.02 is going to tell us flash. Okay, 8.02, here it is again. 7.09. So let's see what's 8.02. Aluminum sill pan flashing with finish to match storefront. Install per manufacturer's recommended details. Okay. They have a tag 8.04 for brake metal. Maybe they're using that here. Here, they're using it here. Perfect. Okay. So GMJ3. So don't use it here. Okay, and if we go back to the window elevations, just so we're clear. Okay, J2, J3. Okay. Okay, so the C flanks D and the J3 conditions, so they want to put some cladding on the post in between, alright? And then they want to have the cladding kind of to cover at the floor condition. So it's 2 pages. They want to have this condition S2. They want to have this condition. Yeah. So this is S1, so that's at the ground floor, and this is S2, so that's the second and third floor. Okay, so basically we know the whole scope of work for the storefront systems on this project now. So what I'm going to do with that information is I'm going to create a new proposal. Just call it a contract review demonstration. So I'll create that. I'm going to add a storefront system. In this case, I'm just going to use TrueLight 3300. That would be this one. If I wasn't sure what to add, I might type YHS. Here it is, 50FI. So I could copy this. I could paste it in here. And then I could see what would be, equal, same type of system, roughly, right? So if you're not sure what a system is and you can't figure out how to go to the state's product approval website and type in a number when you find it in the plans, you type it right in here And if they give you the wrong number and you can't figure out that, then what you do is you copy the type of system and you put it in here. In this case, I'm going to put 3300. I want the engine 5/16 variant because it's insulated. The plans did qualify that. I'm going to call this exterior storefront. I want to choose a descriptive name that's going to help everybody relate the scope of work of this proposal to the project document. Now the performance that they had, it was the VE2 low-E coating. Okay, this is going to be heat strengthened. I know that because I'm familiar with the Trulight 3300 series. And then the interior light is tempered, so I'll save those changes. And then it's time to put in the elevations. So they did a really good job naming everything. I'm going to go with A. Now that's 17'4". 17'4" is 208 inches. The height is 9 foot, so 108 plus 2.5, so 110.5. 1, 2, 3, 4, 5 columns, 2 rows. The quantity is going to be 1. I have a door here. I don't recall, is it left hand or right hand swinging? So I'm going to go to sheet 12. That was my floor plan. Here it is, a right hand door. Going back to 36. I'm going to click here to put in a door. And it's a single door. It was 1.01. It's an entry door. It's 8 feet or 7 feet tall. Right hand door. Swings out, has a transom, saddle threshold, transom glass. It needs to have a 10-inch bottom rail. We're going to use insulated door glass. The hinge, I believe it was the continuous hinge. It doesn't hurt for us to pull that back up, but I remember. Okay, 3-point lock, surface closer, push pull. That's the door we want. This, you could see in the plan, it's intended for it to match up with the door header, so I'm going to put 84 inches from the bottom of the opening. That should line up with the door header, and then I'll save that. Elevation B. Okay, they have a 7 foot to the horizontal. I'm going to add an elevation here. This one's going to be B. It's 204, 110.5, 5 columns, 2 rows. This is going to be 84 inches for everything. Okay. And you know what I need to do? I need to qualify these mullions. I'm going to save that. I'm going to go back to the plan documents for the project. Okay, structural drawings. I'm going to get these opened up. Okay, now I've looked through the structural drawings twice, forwards and backwards. I do not see where they have developed the wind pressure calculations, but they do reflect the 148 mile per hour ultimate wind speed. They're giving us all of the data that you would need to calculate it if you had a program subscription and a structural engineering license. You'd be all set. So for our purposes, I'm going to assume that the design pressure is 50 pounds a square foot. And for this project's location, that's not too terribly unreasonable. So now I have to go back to the proposal, back to elevation A. I already have drawn this. I'm going to put in here in the structural constraints 50 pounds and 50 pounds. I'll double check my mullion. It is calculating, so if it doesn't have the section properties input for the mullion, it's not going to calculate. If it fails, it turns red. If it doesn't have values, it doesn't do anything. So you really need to, click on this, check it, make sure that your deflection and your stress are deflection, it should be less than 1/175th. And the stress, you definitely want that to be less than 10,000, 9,500, maybe pushing it. The rule of thumb is that you need to check on the stress and the deflection to qualify the structural adequacy of the mullion part. So I'm going to save that with the design pressure added, and I'm going to do the same thing for elevation B. Change my structural constraints to 50 pounds. Double check that, yep, we're getting deflection. Okay, save that. Now add elevation type C. So this is going to be 96 by 40 inches as one column with 2 rows. This row, okay, I'm going to want this top glass height to match what I have in A and B. So I'm just going to save this. Pulling this up. Whoa. Okay, in the top row, my height is 22 5/8. So I'm going to set this to 22 5. Okay, and my takeoff document, I have a quantity of 12 type C. So my quantity is changed to 12. Structural constraints, 50. We expect it to pass, no problem. If I put the positive and negative, bid unity is going to use the whichever value has the greater magnitude to calculate the deflection. So if I only put 50 in one of them, it's qualifying it as though I put it in both. So this is type D. Opening width is 120, height is 96, 3 columns, 2 rows. In the top row we had 22.625. I'm going to apply that to everything. I'm going to add 50 pounds, and my quantity here, it's half of C, so it's 6. Save that. Now I know that I have some brake metal to add, so I'm going to add in here brake metal. Let's say sheet metal covers. I like to adjust the thickness of this even though it's not glass. I like to adjust those values, and then we'll go ahead and add a sheet metal cover. Let's go back to our details. So I don't like the detail that they have, and I have some experience doing this differently. I'm thinking that this is going to be a much better approach. They're going to have a column, that's shown their steel, and then we want to get our storefront sealed into this, and we want to have covers that allow us to align them vertically from one floor to the next. If we just wrap whatever they provide, maybe they don't provide these columns aligned vertically from floor to floor, And they have no incentive to do that, whoever installs these columns, because they're not going to be part of the finished work. They're going to be covered up by something. And I know the plan shows it capped with brake metal, and so you would fix the position of it, but we're going to install it in a much better, easier, trainable, teachable, reproducible way if we follow this approach that I have here on the right. And so if we look at the dimensions of this stuff, we just kind of have to guesstimate our way through it. We'll call this column cover. Let's call it exterior column cover. And the width of the metal strip I need to cut, we'll call that 1 inch, 2 inches, 7 makes 9, 10, 11. Okay, a sheet is 48, so let's just call this 12 inches, so we'll get 4 of these per sheet. And the height of the sheet comes 120, and the number of columns we put, that corresponds with the number of bends, so that would be 1 face, 2 faces, 3, 4, 5. I'm going to put 5 columns. There's a little bit of labor associated with each of the columns. A quantity, we have 2, 4, 6. There's 6 elevations on the second and third floor, 3 each. So that'll be 6, and there's a total of 2 columns in each. So we have 12 of these. So we'll save the exterior column cover. That's what's drawn here in the red. And then the cleat is shown in yellow. So we'll have exterior column cleat. And then the width of this, it's going to be 7, 8, 9, 120, 3 columns, quantity is 12, we'll save that. And then we have an interior cover, that's just going to be 1 7-inch wide strip with a 1/2 inch fold on either side. The minimum that you can clamp into the brake machine to fold, you need at least a 1/2 inch, so that looks about a 1/2 inch. So we're going to have, let's add this, interior column cover. We'll make it 8 inches by 120, and the columns 3, and a quantity of 12. Okay. And then in their plans, they're showing us they have metal that comes underneath the frame. We've done a similar storage project and looked at the dimensions and what this is. I have a detail, let's see, I have a detail to reflect that. It's right here. So that foam trim on this other project was about 3 inches. That's about 1 inch. So 3, 4, 5, 6, 7, 8, 9, 10 inches. Let's just call it 12 because again, sheet's 48 inches. We have a table that shows what the profile, how much metal it consumes. So 318, it's not even on the sheet, is it? 318, 3, 11, and 13, 16. So I wasn't too far off guessing 12. So I have all the dynamic page numbers here in my table. I didn't use auto text. It just references page 16 because I typed in 16. I recycled this content from a previous shop drawing. Okay, so we're going to call it, let's just call it 11 and 13 sixteenths as we add these in here. So my sill cover, I'm going to call this second, third, floor sill cover. It's 11.8125, and I'm going to make these 120. And remember, the C frame is 40 inches. Let's go back. Okay. Well, 17'4", and when we look at the elevation drawing, we have two of these and one of these. They kind of line up evenly. If I go back to sheet 12, it wasn't 12, what was it, 26? Let's see, elevation drawing, 29. 29. Yeah, so C and D basically line up with the full width of A, and that's on 36. And here it shows us it's 17'4" which I believe is 204. Plus 4 is going to be 208. So on the sheet metal I buy it at 120, I'm going to make two pieces, that's 240. So I need two pieces per each opening, and I have 6. 6 times 2, that's 12 pieces that I need. So I'm going to need 12 of these. The columns, this is, let's see, this is a little bit more tricky. I have 1, 2, 3, 4, 5, 6. Okay, 6 columns, 6. I'm always going to have one row here. And a quantity of 12. Save that. And finally, I have in the project documents here, I have an energy code report, so I'll get this opened up. So here I found the section of the report that's the input data. That's the data for the performance of the windows in particular. That's what the report relies on when it calculates a pass-fail result. And this tells us the U factor that they use for the different elevations. You can see 1.98, that's quite a high value. 0.26, that's basically the summertime center of glass value. It appears for the fixed frame. That's like an imaginary value. You can't achieve that at all. Solar heat gain coefficient, they have 0.82 and 0.37. Visible transmission. Then they have our sizes, 12 by, looks like 12 wide, 7.2 tall, total square footage. So what do we do with this? It's a little unusual. You have 1.98 and 0.26. It's a little unusual because whoever puts in 0.26 doesn't have a clue about what the window performance is. They're just putting in some glass value. They don't understand what they're doing. Why would they even bother putting in a different unique value, 1.98, for something else? What we need to do to reconcile this is we need to reference the code. The code allows us here, an area weighted average shall be permitted to satisfy the U factor requirements for each fenestration product category listed in Table C 402.4. Individual fenestration products from different product categories shall not be combined in calculating an area weighted average. So C402.4. Okay, so this is it. Fixed, operable entrance doors. And if we go back to what does the project entail, we have one single door, and I believe it's the east wall, so here. So is it a door or is it fixed fenestration? Which is the correct U factor? The code pretty clearly indicates that you can't take the weighted average of doors with fixed fenestration. Clearly the transom is fixed. Clearly the door is operable. Just deduct 21 square feet. What I was able to do is put together a spreadsheet where I take the values from the input data report, including the total areas, and then U factor 1.98, area 86.4. If I multiply these out, I get a total amount of U factor. Okay, and I go on down the line. Now for the solar heat gain, same thing. If I find the total area of the whole entire thing, and then I find the total allowed U factor, so that's U factor times area, that gives me U factor. Now if I take the 780 and I divide it by the total area, that gives me the weighted average U factor. That's what's allowed according to the input data report. And I can do the same thing again with the solar heat gain. So this is how I get the performance values that we need to meet. And this is pretty rare. Most of the time, they're going to use the same U factor, the same solar heat gain, the whole way through their input data. Okay, so how do I use this information? I need a U factor 0.57 or less, a solar heat gain 0.45 or less. I'm going to refer back to my glazing system thermal performance cheat sheet. I know that I have to have an impact resistant system, so that's got me in the 2.5 by 5 inch category. If I don't have insulated glass, it doesn't meet any of the energy requirements. If I have a non-thermally broken system, I could expect a U factor of 0.48. That is better than 0.57. So I don't need to consider using a thermally broken system to save 0.05 U factor. Solar heat gain is 0.25 for this system, and that is based on having a center of glass solar heat gain 0.27. So what I'm allowed, according to the input data report, it's 0.45. So if I take 0.45 minus 0.27, I get 18.4. Okay, so if I take 0.27 plus 18.4, maybe my solar heat gain, it could be as high as 0.45. Because when you look at 0.27 in the glass, and it comes out with the frame to be 0.25. So the solar heat gain of the frame, it's actually slightly less than the solar heat gain of the glass. So I could conceivably get a glass solar heat gain up to 0.45, which that's perfect, because if you go back to the glazing specifications, they specified a solar heat gain 0.37. That's corresponding with the VE-2M low-E coating that they specified. So I'm looking for a comparable type of low-E product according to their input data report. Seems to line up with the specifications they have everywhere else. Got the wrong dimension on frame type B. I'm just going to take that from 204 to 208 and save that. Now I'm taking a quick look over everything. I have all the elevation image files loaded. That is a signal to me that all of the processing associated with saving the elevation, generating the parts list, all of that occurred. Now I'm going to click on price and quote. Now here I'm looking for a glazing type, something like a Solar Band 60, solar heat gain in 0.37. Ballpark. So I want to look at a reasonable cost and type of glass. So Solar Band 60, 28 a square foot with Century glass. I guess. Select that for the door glass, and then for the fixed frame, I think we should be finding something around 21. Okay, PVB, yeah, that's number 2. It's on air. We're using 3300 series, so that's at 20. I think that should be good. I like to sort the part, I like to sort by the part name once I select what it is that I want to use, and then I can get pricing adjacent to it. Okay, yeah, that's gray, red. Anyway, $20 a square foot, that's probably pretty reasonable. Looking at the labor, okay, field labor, $9.85 a square foot for installation. That's reasonable. Manufacturing, $7.48. I'm expecting we should be able to be about $5. The total area, it's 1,100, so that's maybe $2,000 of potential savings in the shop, and that only accounts for, you know, if I'm expecting we're going to be $5, that doesn't include, you know, fully the transportation of the material to the project site. So I'm comfortable at 17. I would be a little bit alarmed if this was anywhere south of 12, given that we have you know, horizontal in the frame system. The fasteners, Tapcons, I know for this system we're typically using a 4-inch long Tapcon, so it's a little bit more money. Let's see, let's get a 4-inch Tapcon, so we're going from 1030 to 16. Okay, the sealant type, we have Dimonic FC, seems reasonable. Baccarat, cartridges, yeah. Door components, typical standard stuff. Glazing accessories, hardware. Okay, and our sheet metal, let's see what we have. $123. Let's see what other pricing is available. I think our cost on sheets is closer to $150 currently, especially on something as small as this. I'm going to select that. Let's see. Yeah, so we're going to need about 12 sheets of metal to produce this whole thing with the column covers and the sill covers. I'm looking at the labor, manufacturing labor. I mean, to me, 12 sheets, we got to cut them up in pieces. If that takes more than, I think 2 guys could have that done in a day, especially if we bring in the metal already sheared. Field labor for installation, it's potentially going to take 3 or 4 days, so we might come out a little short on that. But on balance, I don't think it's, you know, I don't think it's too far off from potentially what it could be. So total $51.74 a square foot. That's our cost to install it, plus $13.34. Seems reasonable. Now we'll look at what do we need to add to this. I would expect we're going to use a telehandler. Okay, 10,000 pounds for a month. That seems a little excessive. 8,000 pounds for 8 days. I think that's pretty reasonable. Let's looks like I got the wrong one. Huh. Okay, so that's the one I want. I'm going to select that one. select that one. Cancel out of this. Seems like I'm having an issue adding the expense. Okay, 8,000 pounds. Let's select that. Quantity 2. I'm going to put this as equipment. I don't like to get too specific about what equipment, what exactly is being added. I'm also going to need to add a boom lift. I want to include about $3,000 for that. So, looking for something about $1,500. Okay, we'll go with this one. Select that. We'll include that for 2 weeks. And then we'll look at assigning a margin. Okay, so my cost basis is almost 70,000. If I go to settings and look at my margin schedule, at 70,000, it's in the 35% range. So if I look at, okay, proposal overhead, I included that independent of the storefront scope, but really all of this stuff relates back to the storefront scope. So I'm going to update the margins so that we have a competitive proposal. I might not always do this. It might be somewhat more subjective. It depends on the nature of the project, the nature of these different scopes, but in this case, that's what I'm going to do. It makes sense to me that we can perform all of this at the same time. So here we have it updated, and I might finalize this proposal, but the reason for me to do this proposal is so that I could compare it to the proposal that we originally created when we received the contract offer. So I pulled up that proposal, and I can see here I'm at 109,361. That proposal's at 104,673. So this proposal, it's based on Coral 500 series, where we're using the TrueLight 3300 series, Coral 550, excuse me. So AB11, C12, D6. Quantity is the same. Brake metal, okay, column C and D, column covers. Okay, we have, looks like 16 pieces. Okay, 16 pieces. I'm not entirely sure how we get that. In the elevation, we have one elevation has 2 columns, so we have 1, 2 outside, 2 inside, that would be 4. And then we have 6 of these, so we might have 24. We have 12 columns. What does that correspond to? 12 columns, and the extra 4, I'm not sure. Not sure. Okay, we have a different column, number of column covers. Silpan A, alright, then 6 inches. Silpan B, 6 inches. I don't include anything on A and B. That was the detail at the floor. Was that on page 38? Yeah. Yeah, so that's right here, kind of going into the expansion joint. I mean, maybe they're going to ask us to include something, but I don't know. Not likely, I don't think. Silpan A, 6 inches by 208. Okay, B. C, we have 12 pieces, 6 by 40, and D, 6 pieces, 6 by 120. Okay, so the 6 by 40, those pieces are going to be, for the purposes of optimizing material in Bid Unity, it's going to consume the same amount of material as if it's 6 by 120. So you have 12 plus 6 is 1,820-inch pieces at the sill cover, and I have 12. So there's an extra 6 pieces just based on, I know it's not intuitive, but how this is put in, there's an extra 6 pieces. So I don't have these, and here I have 36, so that's 18 plus 6, 24. I mean, the quantity's not terribly far off on balance, but we arrived at the quantities differently. Our storefront frames are the same. When we look at the budget for brake metal, we got 4,000 versus 8,600. Okay, 884. I'm wondering if we go back to this proposal and then we look at which part was selected, parts by vendor. Let's find that sheet metal part. Okay, so it's 147. Okay, only 6 pieces. Okay. Yeah, so if you're 6 inches wide, you're getting 8 pieces out of this. Whereas if I'm 8 inches wide, I'm only getting 6. So I need 2 sheets for this. And for this and this, there you need just a little bit more than 2 sheets. Okay, and we have 6 inches here. I have almost 12 inches, 9 inches, 12 inches. So, yeah, it makes sense. I'm using a lot more material. And let's see, all of our columns and rows are 1 by 1. If we go to the system configuration for brake metal, let's see, mullion represents a bend. Okay, so the total labor for parts is 7 minutes labor per bend. So for every bend, the system configuration is going to add 7 minutes of labor. If we go back to our budgets, we should see field labor, manufacturing labor. Yeah, my manufacturing labor, it's substantially more, just resulting from, you know, columns and rows. We're not including all of the bends, and what we want to do is, you know, include all of the faces. So that's 4,600 of difference. If we look at the storefront, looks like I am another $4,000 of difference in the storefront. So I should be 9,600 more. So I'm about 5,000 off, and I see we have a hotel and a per diem charge. I didn't look to see where we're performing this job. If we pull that up, we're going to see it's clear on the other side of the state, so that's greater than 50 miles from our shop. So what I need to do is add in here some hotel and per diem. So I'm going to select the per diem, And how many days? I'm going to put 52. I'm going to call this travel related expenses and add that. And then I need to include the hotel. I'm going to include this as a miscellaneous work expense and call it 3510 travel related expenses. I'll add that. I'm going to go back to finalizing, and I'll go back to the proposal summary. So where I'm at on this right now, I have $4,600 or $4,568 more for brake metal. I have $3,970 more for the storefront. This is the TrueLight approach versus the Coral approach. And then I'm carrying an extra $3,000 of overhead. And if we look at, we have the same hotel, the same per diem, $2,300 for a lift. I have a lift in here at $2,700, so about $400 more for that. And I'm including a forklift so that I can pick up pre-glazed units and install them. So my overhead is $3,086 more. In total, doing this with TrueLight as I have it, it's $11,600 more costly. So on balance, I have $4,568 more for brake metal. I have $3,970 more for storefront, and I have $3,086 more for overhead. Those are selling prices, proposed value, differences in the proposed value. They're not so extreme if we consider the difference in the cost basis. Okay, so the way that I square all of this, I prepared a spreadsheet to show my thinking. When we're looking at the proposed prices, what I get for the Coral system, the contract price would be $104, and what I get with the TrueLight system, the contract price would be $117. It's a substantial 13% difference. If we look at this on a cost basis, the differential in cost, it's $5,200 more to perform the job with the TrueLight approach. Now, we have a contract offer for $104,000. The margin that we get, theoretical margin that we get using Coral, is $35,500, and the theoretical margin with TrueLight is $30,000. So there's a difference of $5,200 in the margin. That's the same as our cost. The cost differential reduces our margin. If we look at the field man days that are associated with performing either, the way that I get that at is by looking at the field man days for the Coral storefront, and then on the TrueLight side, I'm looking at how we have this set up with the field labor. I have some glazing labor in here that is not correctly allocated if we're going to glaze these panels in the shop, but even neglecting for that, if we take the ratio of $9.85 a square foot relative to the 17, multiply that out by 44, we can estimate a difference, of course, correcting for the glazing labor. Having previous experience pre-glazing panels and looking at the cost difference from a center glazed storefront installation to installing pre-glazed panels with equipment, we're realizing 30% field labor savings. And so just for the purpose of this analysis, I'm taking 80% of the Coral theoretical field man days as a baseline for what the true light man days are going to end up at. It seems reasonable that 4 guys in 5 days can set 1, 2, 6, 7, 8 openings. Any rate, if I look at the margin being generated per man day, I have almost 1,300 and I have 1,382. So if I want to get the best return per resource, and I think that our field labor truly is the constraining resource in a lot of our business. If we want to get the best return on that constraint, then we need to look at approaching the installation in the most efficient manner that we can from the standpoint of conserving the field labor. And so I have a preference. I think economically we're rewarded for being more efficient on the job using the True Light system, even though it reduces the potential gross margin by about 5,200. And the way that we can profit from this is by, of course, doing more jobs. In addition to that analysis, I'm also thinking about our experience on storage projects, and we're regularly asked to come back because it's leaking, and I have a very strong preference for the 3300 series over a center glazed frame because we do not need to get married to the leaks and chasing the water, because it's so obvious. 3300 series, it's not going to leak unless there's a hole in it that you can see with your eye. So for all of those reasons, I have a preference for the 3300 series. So I just updated my margins to get as close as I can to the accepted proposals price. And I'm going to finalize this. And then once I have it finalized, I want to make sure that I give it the name Contract Review so that it clearly indicates that's what the proposal's purpose was and that the scope of work is reconciled. If I end up making subsequent changes, I might say R1, R2, and whatnot. In that case, I'll reference the proposal number that I'm copying. So this proposal is 10461. I would prefix any subsequent copies of this with 10461. I want to indicate what the origin of the proposal is. So I'll save that. And then I want to make sure that the project doesn't have several open proposals. At this point, when I finish the contract review, it should have the accepted proposal and it should have the reconciled proposal, and all other proposals should be rejected.